Hey engineers, and welcome to 1.1, which is entitled The Engineering Notebook. We are going to talk today about your engineering notebook and what makes this a really important thing for engineers. This is actually my engineering notebook, specifically for, you may have or may not have noticed that I have automated blinds in my classroom. I go back here, and there's a knob that I can turn. If I turn that knob up and down, the blinds, they raise and lower on stepper motors. So this engineering notebook is where we did all of our work. And why it's important, we made those blinds 4 years ago. And when things break or I want to improve something, so for instance, that's a knob that you can turn. Maybe I want to change that to a slider. What resistances did I use inside that potentiometer so I can match that to make it a pretty plug-and-play device? Or if it wasn't, can I go and look at the code for my microcontroller that we programmed over there and just adjust the code to then whatever that new resistance is? So inside of here, it's kind of fun. We have, just to show you, we made a picture of the room because we had to have some cables that would go across the entire room. We documented our, what's the word I'm looking for? When you attach the wires, the color codes inside of there, dimensions for the plates, some rough sketches, torque curves for the stepper motors. So how much force do we need? Do we need to gear these? How large of a gear do we need? And so on. So this is a really good reference for us in our calculations. Like, how do we figure out how much torque did our motors need to provide? We actually went to each one of those blinds and we would pull on them with a force scale to figure out how much force does it take. Okay, so then if our gear is like 1 inch in diameter, how much torque does it need to create that much force to actually have enough force to lift and raise those? So engineering notebooks are for exactly that. Here's your engineering notebook. Inside of it, here's what a general page will look like. Whoop. Kind of fun. We're going to talk about why they're so important, specifically to engineers. So let's get going. We're going to talk today about what is an engineering notebook, why do you keep it, who keeps this, what do we put inside of it, some of the sections that you're going to find, the standard page layout, you kind of got a picture of that as you saw the other one before, some best practices and some examples from history of other engineers' engineering notebook. The engineering notebook, it's a book in which you document yourself in chronological order when you're associated with a specific design. My friend Nancy gave me this from NASA. This is an actual NASA engineering notebook, but the actual engineering notebooks that they use are they're hardcover. Nancy has an entire library of these of her work throughout her entire career. It's in hardcover. We'll talk about why it's hardcover and why you don't rip pages out and so on. Specifically, it's because it's a legal document. Like a lot of times in a capitalistic society, if you think of an idea, you can make money on that and you can patent that and then continue to make money off something. So your engineering notebook primarily is a legal document so that you can claim ownership to then make money off of that. So it proves the origin, who thought of it. It proves when, so there's a date. It proves diligence. So you saw my calculations for torque. Like at some point your boss is going to say, what size motor? And maybe you're dealing with like a $20,000 or $100,000 motor. We don't want to just go buying some huge thing if you haven't shown us that that's truly what it should be. And prove when an idea has become a working solution. So as you've iterated it to make it better. Who uses them? R&D, that's the engineering world for research and design. So people who are researching for the future, designing for the next model that comes out. Legal document, continuity. Engineering students. So you are going to use these, and the next assignment that you're going to have at the end of class today is you're going to be building a tower. And it's really an example of how to use your engineering notebook. Some of the things that your notebook should have. the problem. Believe it or not, that's half the issue when you're dealing with an engineering problem, is like, what is the problem? Inside of Hunch, when we work with NASA, our first meeting, we sit down with our project managers and they have us restate the problem in our own words. Because if we don't define the problem correctly, there's no way we're going to solve this thing. Your research. So what sorts of torque curves do you have? Like we printed those torque curve specs right off of the internet. Sketches. What are some of the things, ideas that you have, distances, brainstorm ideas, calculations, and your daily thoughts. Basically everything. When you're going through building a project, this is where you throw everything. You never do something on loose leaf. You always put everything inside of your engineering notebook. Expert input. Believe it or not, we actually had to have someone from the university come and help us with the wiring of these because we worked for a week to figure out those stepper motors. So we had to hire in a contractor to help us figure those out. Testing procedures, digital and technical drawings, design modifications. Some of the things that you're going to have inside of it: a title page, table of contents, which you can see here. General chronological entries, so they're starting from top to bottom. You can see that these are all labeled with the date. References, business expert contacts. So this is what yours looks like. It literally looks, I think, exactly like that. Exactly like this. Proprietary information, right down to the bottom right, that this is saying that it's copyrighted. It's quadruled, so it will help you make graphs, helps you make kind of like scale drawings if you need to make pictures. All the pages are numbered. It's really important that they're numbered because that way a page can't be ripped out or a page can't be inserted. So it's in there legally to help prove that this is the day. I didn't just inject this page. Dated, signed with the designer, signed by witnesses. It literally has all of this stuff on the bottom of yours. And a statement saying that it is copyrighted. It's proprietary. Maybe you've heard of industrial espionage, specifically China. I mean, we do this, also, but stealing our ideas, taking them back to be manufactured cheaper in China. Best practices. Your work should be in pen, and you might think that that's counterintuitive. Like, what if I make a mistake? It's okay to make mistakes, but it's important that's in pen because you can't erase it. So it can't be put in there after the fact. Pen always. Markers that breathe, you don't want to do that. Sometimes I will only write on the right-hand side. I don't know if you probably couldn't see that, for instance. Like in my engineering notebook, I only put stuff on this side so that it doesn't have a chance to bleed through. And they are bound. You can't remove them. These are not perforated so you could tear them out. They are stuck in here forever. When you finish, so you'll see that this person right here was doing a little bit of research on diodes, and when they finished, they drew a diagonal line, and then they signed it. That means that when you're leaving something blank, kind of like a check, if you write 100, you don't want the person behind you to write 1,000. So you are putting this line here to show that I have finished this page. I am crossing that page out. You signed it, and then you dated it at the bottom of each one. Don't leave a blank space. If there's extra, draw that diagonal line saying that I finished. Nothing new should be going here, and sign across it. If you do make mistakes, and you can see here that this person doing some research, if you make a mistake, just make a single line and then write in your corrections. It's important to be able to see what was your mistake. Like if you made a calculation error or if you spelled something wrong, it's okay for us to see your mistakes, and you need to make a single line through them when you do make a mistake. Never erase or remove anything. It should be in pen. You should have to make a line through it. Date each entry. There'll be a spot for a date at the bottom of each one of your pages that you can put all of your stuff in. So here's some entries: 5/13, 5/15. If you have things to put inside of your engineering notebook, you can tape them in. So that's kind of what I did here. To a drawing that we did, we taped it in. And what you can do is you can sign across it to just show that this was put in. You can sign your name across the crease to show that this was put in there. prefer glue, you can use tape, but signing across it is a really great way to show that this belongs and this was put in there at a certain date. Sign and date each page before you begin the next one. So you go in page order. A colleague or mentor should sign it to show that you've signed off on it. So there's a spot for your name right here, and then there's a sign for my name and a place for me or your boss or your colleague or whatever to date that. Stored in a safe location. When you do your sketches, it's really important to try to label your designs the best you can, because believe it or not, like these things over here, it happened 4 years ago, and I don't remember what we called stuff. I don't remember. It's there for you to come back to, or if you end up leaving this and you hand this project off to somebody else, being as detailed as you can to help them understand what you were doing, what you were thinking, and why you did that. All of your calculations are clearly labeled. This is going to be a struggle for some of you, being neat. I know it's a struggle for me. That just means slowing down. Reflect on task, accomplish successes, failures. So reflections, meaning what worked and what didn't work. Because again, 4 years later, I'm looking at these blinds. I'm like, hey, you know what I should do? But if we made a note that we already did that, yes, that would save us lots of time. Hey, we tried this. It didn't work. We tried this. It did work. We tried. If we were going to do it again in the future, here's what we would do to finish that. Reflections. Neat, accurate, legible, thorough. Here's some examples from history. Earl Silas Tupper. Maybe you've heard of Tupperware. Here's an example. He was alive up until 1983. Here's the page out of Everett Huckley Binkley's original design notes for an electromechanical fly catcher. How do you catch a fly? Looks like some rotating metal cylinder. There's some bait here driven by a Techron clock motor at 1 RPM. So very specific with the dimensions and like the speeds there. Maybe if you play tennis, Head, it's actually after Howard Head. That's his name. That's a brand of racket. So here's one of the very first ones that wasn't wooden. Binder. So you've got a 3-ring binder for a lot of the stuff. Actually, you're taking notes in a packet right here. But have a 3-ring binder for all of those. So we're going to be getting a lot of these throughout the year as we talk about different ideas, but putting your stuff inside a 3-ring binder. Your notes, not your engineering notebook. Your engineering notebook stays your engineering notebook. No, we're not going to be keeping them online. So that's it. The engineering notebook. So here's actually your first project in Principles of Engineering. It's called The Tallest Tower for the Taxpayer's Tariff. What it is, it's really an exercise in can you use your engineering notebook effectively. So it's really an exercise for your engineering notebook. It says you're a civil engineer working for a company who's trying to get the job designing a new tower for the city of Platteville. Kind of like the Belmont Tower, but we're going to call it the Platteville Tower. Your goal is to construct the tallest tower for the least amount of money. The citizens are counting on you to spend their hard-earned tax dollars wisely. The winning design will be chosen by the city council, and they're using a metric called the height cost coefficient, or HCC for short. The height cost coefficient is found by dividing the height in millimeters divided by the total cost in dollars of your tower. And then you're going to multiply it by a constant of 1,000 to just make it a number that we can easily look at. Whatever tower maximizes the HCC will be awarded the multi-million-dollar contract, and the designers will be given $20,000 bonus by their respective companies. You're going to get the rest of the period today to work on this with a partner. You are not going to be able to construct anything today. So today is going to be in your engineering notebook brainstorming. You have to come up with 3 different design ideas in your notebook before you can begin building. There's a limited number of items, so first come, first serve. here's all the things that you can be able to use. 8.5 by 11 sheet of paper, a 1 inch of Scotch tape, 6 inches of string. And you can buy 5 sheets of paper, but then remember that's just 5 times 19,000 or 5 times 20, 100, and that's $95,000. And then you're going to divide by the height, however you choose to do that. So here are your things. I'm going to cut you off at this point. I'm going to let you get into your groups and do some brainstorming. You won't be able to start building anything until tomorrow. So good luck, and use those best practices inside your engineering notebook. Ooh, I forgot to tell you one last thing. It's nice. Your engineering notebook has a table of contents, but if it doesn't, your first page should be the table of contents. So write table of contents on the first page, and when you start brainstorming for your tower, do that on the next page. Peace.